Alan Turing and John McCarthy are often regarded as two of the most pivotal figures in the history of artificial intelligence, each contributing foundational ideas that shaped the field in profound ways. While Turing is remembered as the father of modern computing and the architect of the theoretical foundation for AI, McCarthy is known as the man who gave AI its name and introduced groundbreaking concepts that expanded the boundaries of what artificial intelligence could achieve. Let's start with Alan Turing, whose work in the 1930s and 40s redefined how we think about machines and computation. Turing's 1936 paper on computable numbers with an application to the Entscheidungsproblem introduced the idea of the Turing machine, a theoretical device that could perform any computation through a set of simple instructions. The significance of the Turing machine was profound. It demonstrated that any process that could be described algorithmically could, in theory, be carried out by a machine. This laid the groundwork for the concept of general-purpose computers and inspired future generations to imagine machines capable of more than mere calculations. Turing's contributions didn't end with theory. During World War II, he applied his brilliance at Bletchley Park, where he helped crack the Enigma code used by Nazi Germany. By building the bomb, an electromechanical machine that automated the decryption process, Turing played a crucial role in the Allied war effort and demonstrated the practical power of computing. His work showed that machines could augment human intelligence and perform tasks that once seemed impossible. But it was Turing's post-war work that most directly shaped the future of AI. In his 1950 paper, Computing Machinery and Intelligence, Turing asked a provocative question: can machines think? Rather than getting bogged down in philosophical debates, Turing proposed the imitation game, now known as the Turing test, as a practical way to assess machine intelligence. The test posed a simple challenge. If a machine could engage in a conversation indistinguishable from that of a human, should we consider it intelligent? The Turing test wasn't just a technical proposal, it was a philosophical statement about the nature of intelligence. Turing argued that intelligence could be demonstrated through behavior, regardless of the internal processes behind it. This shifted the focus from trying to replicate human thought processes to evaluating the outcomes of those processes, a perspective that continues to influence AI research to this day. However, the development of AI as a formal field didn't begin until 1956, and that's where John McCarthy enters the picture. While Turing laid the theoretical groundwork, McCarthy gave artificial intelligence its name and formalized its mission. In 1956, McCarthy organized the Dartmouth Conference, a summer research workshop at Dartmouth College that is widely regarded as the birthplace of AI as an academic discipline. McCarthy and his colleagues, Marvin Minsky, Claude Shannon, and Nathaniel Rochester, believed that machines could be taught to reason, learn, and even improve themselves over time. McCarthy's vision for AI was bold and ambitious. He believed that intelligence could be described as a series of logical operations and that machines could be programmed to perform these operations. But McCarthy's most influential contribution was the development of LISP, a programming language designed specifically for AI research. Created in 1958, LISP was revolutionary for its ability to handle symbolic data and recursive functions, two capabilities that were essential for building intelligent systems. LISP became the de facto language for AI research for decades, powering everything from early expert systems to robotics projects. McCarthy's work on LISP demonstrated that programming languages weren't just tools, they were frameworks for expressing complex ideas and building sophisticated systems. McCarthy's contributions extended beyond LISP. He was a pioneer in formalizing the concept of time sharing in computing, which allowed multiple users to interact with a computer simultaneously. This innovation not only made computing more accessible, but also laid the groundwork for cloud computing and interactive systems, which are now integral to modern AI applications. One of McCarthy's most ambitious ideas was the notion of common sense reasoning. He recognized that for AI to be truly intelligent, it needed to do more than solve mathematical problems or follow rigid rules. It needed to understand and reason about everyday situations. In the 1960s, McCarthy proposed creating an AI system with a comprehensive database of common sense knowledge that could be used to infer conclusions about the world. While this vision proved more challenging than expected, it inspired ongoing research in natural language understanding, contextual reasoning, and machine learning. McCarthy's approach to AI was characterized by optimism. He believed that artificial general intelligence, machines capable of reasoning, learning, and acting across a wide range of domains, was an achievable goal. This optimism shaped the early AI community and set high expectations for the future of the field. While Turing's work focused on defining what machines could theoretically achieve and proposing ways to measure intelligence, McCarthy's legacy lies in defining how machines could be built and programmed to pursue that goal. Turing laid the philosophical and mathematical foundation, while McCarthy provided the tools and frameworks to bring AI to life. Despite their different approaches, both men shared a profound belief in the potential of machines to transform human life. Their contributions continue to shape the field of AI, from the symbolic reasoning of the past to the machine learning systems of today. Reflecting on Turing and McCarthy's legacies reminds us that the pursuit of artificial intelligence isn't just a technical endeavor. It's a quest to understand intelligence itself. It's a journey that bridges the abstract and the practical, the theoretical and the tangible, and the past and the future. Their work invites us to ask not just what machines can do, but what we can learn about ourselves by building and interacting with them. Today, as we stand at the forefront of AI innovation, we owe much of our progress to Turing's vision of machine intelligence and McCarthy's drive to make that vision a reality. Their contributions remind us that breakthroughs come not just from solving problems, but from daring to ask the right questions. The story of AI continues to evolve, but its roots remain grounded in the work of these two pioneers, one who proved that machines could think and one who believed they could one day understand.